Continuing with my previous video, which was uploaded on theory part of Simpsons Rule, where I explained and clarified how do we proceed solving questions on Simpsons Rule. That was the theory part. So to back it up, we now do two questions. I have selected two questions from past papers for Chief Mate Phase 1. Okay, this first one is on calculation of area and center of flotation, and the second one will be on volume and kb. So most common are these two. Okay, let's read through the question. A ship's water plane is 180 meters in length. Half coordinates of the water plane commencing from forward are as follows: 0.4, 4.4, 8.8, 11, 11.6, 11.8, 11.6, 9.6, 7 and 0.4 meters respectively. The spacing between the four middle ordinates is twice that of the others. Okay, calculate our water plane area, TPC, and position of the center of flotation with respect to the mid length. So what all things I have to focus on? First thing is that I have been given half ordinates. So I will get half area. I must multiply by 2 in the end to get the full area. That's the first thing. Then I note that my ordinates which are arranged here are commencing from forward part to the aft part. So you're going from forward to aft. So 0.4 is the forwardmost one, and then you're going to aft. The aftermost is also 0.4. Spacing between the four middle ordinates is twice that of the others. So you have to identify these four middle ordinates. It's very simple. How many ordinates are given? Total how many ordinates? You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ordinates are there. So there will be 9 sections. So number of sections is always one less than number of ordinates. So there are total 9 sections. Then 4 ordinates in the middle. 4 middle ordinates. 4 ordinates in the middle will cover 3 sections. Okay, so out of total 9 sections, 3 sections are in the middle. So middle 3 sections will be, obviously you leave 3 sections from forward, you leave 3 sections from aft, you're left with 3 sections in the middle. Okay, so these 3 sections in the middle, he says the spacing is twice that of the others. So in other words, if in the middle the spacing is h in these 3 sections of the middle, if I say spacing is h, then in the forward 3 sections and in the aft 3 sections, spacing is h by 2, half. Okay, so that is identified. What are those 3 sections in the middle? 4 ordinates or 3 sections in the middle identified, and now I mark the common interval. Common interval is h in the middle section, 3 sections in the middle, and it is h by 2 in the forward and aft 3 sections. Okay, now I have to find what is my h. Okay, as you have been told, I have explained in the theory section that h, for calculating h, you must consider how many complete sections are there. Complete section means the ones which are having common interval as h. So in the forward part, you have 3 sections with h by 2 interval. And in the aft part, also you have 3 sections with h by 2 interval. So total there are 6 sections of h by 2. So how many complete h? 3. So 6 h by 2 sections will make 3 complete h. And then we have 4, 5, 6. So there are actually 6 sections of complete common interval h. So 180 meter is my length. I have to divide this by 6 to get the value of h, which comes out to be 30 meters. Right? So this part is well understood because it's important, very important. What is the value of h? Okay. Now, second step is, first I want to see if I cannot calculate this at one shot with one rule. Impossible. Why? Because the common interval is different. It's h by 2 and h like that. So if I do the 3 areas which I have marked, forward half station, I marked A1, the middle section A2, and the aft section again A3. I split them in 3 areas, A1, A2 and A3. So if I want, I can calculate all 3 separately as absolutely independent of each other. I can calculate area A1, I can calculate area A2 and then area A3 and add them up. I will get the complete half area, which if I can apply only one rule in all 3 sections, I can even, do a combined calculation where I don't have to do separately all 3 areas because that will take time. Okay, so in the forward half station, we have 1, 2, 3, 4 ordinates and 3 sections. 4 ordinates means I can use rule number 2. Multipliers will be 1, 3, 3, 1. In the middle, again I have 1, 2, 3, 4 ordinates. Here also I can use rule number 2, 1, 3, 3, 1. Aft, again I have 3 sections and 4 ordinates. Again I can use rule number 2, 1, 3, 3, 1. So confirming that if I do separately all these 3 areas, same rule I can apply in all the 3 areas. In that case, I can combine them and do at one shot only. So as I have explained in my previous video, how do you combine these where the interval is half and where the interval is full, how you combine them. First, write the normal multipliers as if you are doing separately the 3 areas. Like assuming I am doing area A1 separately, so 4 ordinates are there in area A1. My multipliers for rule 2 will be 1, 3, 3, 1. I get 1, 3, 3. I come to the middle section. I have 1, 2, 3, 4 4 ordinates. Multipliers will be again 1, 3, 3, 1. Similarly, in the aft 4 ordinates 1, 3, 3, 1. So first write like this, as if you are doing separately the 3 areas. Now we can, considering that I am doing at one shot, what will happen if I do at one shot? Say start from forward or after, wherever, aft to forward. Okay, let's start from aft to forward. So in the aft, 1, 2, 3, 3 ordinates which are from aft, 0.4, 7.0 and 9.6. So here the interval is h by 2. So the Simpson's multiplier will become half. Okay. So 1 will become 0.5, 3 will become 1.5, again 3 will become 1.5. And as you know, the common ordinate, which is called the dividing ordinate between half station and the main body, multiplier is always 1.5. This has been verified and proved in my previous video. So the ordinate, which is 11.6 from aft, this ordinate is dividing the main body with the half body. So where the interval is half and where the interval is full, it is a common ordinate between the two parts, between area A2 and A3. So the common ordinate multiplier will be always 1.5. Okay, this is very important, that this one. So this is the common ordinate and the multiplier will be always 1.5. Now I come to the middle section where the interval is complete H. No change here. 3 will remain 3, 3 will remain 3. Now I come to the forward part where the ordinate, which is dividing the forward half area with the main middle body. So that will again become 1.5. Okay, because this is the common dividing ordinate between the half station and the main body. Now I have entered the half station. All the multipliers will become half. 3 will become 1.5. Again, 3 will become 1.5. 1 will become 0.5. So I have now new multipliers considering the combination of the all three areas. This is to just reduce the time for solving. Otherwise, you can always do A1 separately, A2 separately, A3 separately, and then add them up. Then you have to find the geometric center. You'll have to find geometric center of A1 separately, geometric center of A2 separately, then geometric center of A3 separately, then take moments and get the geometric center of the full area. Can be done, but will take some time, be lengthy. But if you understand this way, what I have explained, this will shorten up the calculation. But ensure that if you are doing separately, first you have to ensure that if I'm doing separately the area A1, A2 and A3, I should be applying the same Simpsons rule everywhere. Then I can combine them. But if I'm, for example, in area A1, I'm using Simpsons rule number 1, and area A2, I'm using Simpsons rule number 2, then I should do them separately, absolutely separately. It's only if the same rule you are using everywhere, you can combine. Like here in this question, I'm using rule number 2 everywhere. For A1, A2 and A3, all these three areas, I'm using rule number 2. So then I can combine them. Okay. So I will now make a table. First we write the half ordinates, the value which is given. You can write in any order, from forward to aft or aft to forward. It's up to you. They won't make any difference. So I think when I was doing this solution, I started writing from aft to forward. Why? No reason. Just started writing from aft to forward. You can do from forward to aft. It won't make any difference. Okay, so I've started writing my ordinates from aft to forward. See here I have in small, you can write in the exam, you have the pencil, you can write with pencil the value of the ordinates. So I've written here 0.4, 7, 9.6, 11.6. This is the value of ordinates. But first I ensure that I write correctly as per the question. In the question it is given from forward 0.4, 4.4, 8.8. So that I have written correctly from forward 0.4, 4.4, 8.8 as given in the question. I have written correctly from forward end. For solution, it's up to you. You can write from forward or you can write from aft. Okay, so if I I've written from aft. First ordinate is 0.4. From aft, Simpson multiplier is 0.5. Okay. Then this second one is 7.0. Simpson multiplier is 1.5. Then 9.6 is again 1.5. So now I'm writing the Simpsons multiplier after making my corrections. Okay, the ones which I've written in highlight. Okay, so first one 0.5, 1.5, 1.3 will become 1.5, 1.5. Then I come to the common ordinate, which is always 1.5. Then I come to the middle body where no change. So 3, 3, 11, this ordinate 11.8 and 11.6 will remain as 3 and 3. Again, now I come to the common ordinate between the forward half station and the main station. Common ordinate is 11.0. So 11.0, the multiplier for the common ordinate, dividing ordinate will be always 1.5. Now I have entered the half station in the forward part. So multipliers are again half. 3 will become 1.5. Again 3, 1.5. Last one is 1. 1 will be 0.5. So this job you have to do carefully. And once you are confirmed, you have done carefully. Now multiply the half ordinates with Simpson's multiplier and get product for semi area. Because ordinates are half ordinates, so you will get product for also semi area. So each ordinate is multiplied with 0.4 into 0.5, 7 into 1.5, 9.6 into 1.5, 11.6 into 1.5, like this. Keep multiplying and write the product in front of it. Okay, get the products all carefully written. This is a product for semi area. Now levers. Again, you have a choice. You can take your levers from forward or aft, wherever you like. I have taken levers from aft. So the first ordinate, which is from aft, is 0.4. I have taken levers from here. So lever for this particular ordinate will be 0 H. Okay. Now I'm going aft to forward. So the next is ordinate after 0.4 is 7.0. The lever is H by 2, so 0.5 H. Then the third ordinate from aft, the lever will be H by 2 plus H by 2, so it will be 1 H. Then I come to the fourth ordinate from aft. So what will be the lever? H by 2 plus H by 2 plus H by 2, so it will be 1.5 H. So up to here I was in the half station, so that's why the levers were half. It was coming H by 2. So 0H is the first one, then next was 0.5H, then 1H and 1.5H. Now I come to the main body where the interval is H. So the next ordinate is 11.8 here. So you just add H to the last lever, 1H. So the last lever was 1.5H. So next will become 2.5H, because now you are in the main body where you are just adding H. You will have to add 3 times the H. So 2.5H, then it will be 3.5H, and it will be then 4.5H. So you have now reached the common ordinate in the forward part. Okay, which is after 11.6, the 11. After 11.6, 11, you have reached common ordinate. Up to here is 4.5H. After this, you are entering the half stations where the interval becomes half, and h by 2. So after 4.5h, it will be 5h, then 5.5h, and the last will be 6h. So carefully write these levers. These are just distances in the terms of h from aft to forward. Okay. So where it is h by 2, you add 0.5h there, and where it is complete h, you add complete h there. So keep adding like this in the terms of h, and you get your levers from aft. You can do the same thing. You can do the levers from forward. Now multiply the product for the semi area with their levers. So 0.2 into 0 will be 0. 10.5 into 0.5h will be 5.25h. 14.4 into 1h will be 14.4h. 17.4 into 1.5h to 26.1h. 35.4 into 2.5h is 88.5h. 34.8 into 3.5h is 121.8h. 16.5 into 4.5h is 74.25h. 13.2 into 5h will be 66h. 6.6 into 5.5h is 36.3h. And the last is 0.2 into 6h is 1.2h. Okay. Now add up. Add up the sum of the products for the semi area. This column SOP 149.2 for the area, product of the area, add up. Then the moments. These are semi moments because breadths are half. So these are also semi moments. So I add up and I get 433.8 H. So remember that we don't write the value of H till the end. So 433.8 H is the sum of the products for semi moments, and 149.2 is the sum of the product for the semi areas. I apply the formula now for, since I had half ordinates, so half area I will get. Simpson's second rule, 3 by 8 H into sum of the product for semi area. H we have calculated is 30, so 3 into 30 upon 8 into sum of the product for semi area, which is here, this one, 149.2. I get 1678.5 meters square. For getting the total area, multiply the half area with 2. Okay, multiply the half area with 2, you get the full area. This is our first answer, 3357 square meter. Now for center of flotation, because my levers were from aft, so I am getting center of flotation also from aft. If you take levers from forward, the center of flotation will also be from forward end. So don't make mistake here. My levers were from aft, so center of flotation from aft end. So just divide some of the products for semi moments with some of the products for semi area. Which one? This is the sum of the product for semi moments, 433.8 H divided by sum of the product for semi area, 149.2. Okay, 433.8 H upon 149.2. This will give me the center of flotation from aft. Okay, 433.8 H. H is 30 meters. So 433.8 into 30 upon sum of the product for semi area, 149.2. I get 87.225 meters center of flotation from aft. They are asking from mid length. It's easy. See, if this is this complete length from forward to aft, here, this one. So if this is the complete length from forward to aft, you mark the midship M will be 90 meters from aft. Complete length is 180. Midship length is 90 meters from aft. Center of flotation from aft is 87.225. So just subtract 90 minus 87.225, you get the distance of center of rotation from midship. And you can see that 90 minus 87.225 is 2.775 meter aft of midship. Okay. Yes, you can see the center of rotation is aft of midship. Small line can be done, and it is very simply to write the correct. So here I needed MF, center of rotation for midship. So AM minus AF. AM was 90 meter, AF, which I found 87.225, I got MF 2.775, and it is aft of midship. So 2.75 meter aft of midship. Now they are asking TPC in ship is loading in salt water. Remember, for TPC you must use full area, not the half area. Okay, full area is 3357 square meter. So formula is 1.025. This is the density of salt water, density of the water in which the ship is floating into area of the water plane upon 100. So TPC for this water plane area, 1.025 into 3357, total area is 3357 upon 100, 34.41 tons. So that's all was asked in the question. Okay, water plane area, TPC, and position of the center of rotation with respect to mid length. We found everything. So you can, do it yourself. The same question is from past papers. I just selected it because it appeared to be a bit something, it needs some thinking part is required. How to do it in short time, because three areas, otherwise you have to calculate all three areas separately, all three geometric centers separately, and then get the final. That will take some time. But if you know how to do this in the combined manner, like the multipliers can be rewritten. Okay, if you have any comments, you can leave in the comment section and I will answer them. Thank you very much. For now, I am putting up now the second video, which is on underwater volume and KB.